All right, for today's lesson, we're going to be talking about exponential growth and decay. We're going to be looking at some formulas. We're going to be looking at exponential and logarithmic word problems, essentially. And this is going to be a two-part lesson, so this is part one. So first thing we're going to do is we're going to learn the types of formulas that you could have. You should have seen a few of these before, especially in Math 1, continued into Math 3. You may have seen a few in Math 2, but they may look a little bit different, but they are set up the exact same way. So when we talk about exponential growth and decay, you can see that I have A of t, that just stands for my function. P sub 0 just means the initial value. So again, P sub 0 means the initial value. And then we have 1 plus r and 1 minus r. That is how we distinguish the difference between growth. Growth is plus, decay is minus. R is the rate, and t is the time. So again, let's go ahead and establish that this one is going to be growth because it's being added. This one is decay because it's being subtracted. So my pieces, my A of t stands for my future value. So that means if I ask you if I have this much money in the account and it grows at this amount, what will I have in 5 years? They're asking you for the future value. P sub 0 stands for the initial amount or initial value. R is going to stand for the rate. However, you need to take your percentage, and your percentage needs to be divided by 100. You need to put it as a decimal. So the rate as a decimal. And then T is going to stand for time. Okay? That applies to the exact same thing. The difference here is I have compounded growth. So compounded growth means that I'm actually going to calculate this so many more times in a particular, let's say, a year. So if you notice, everything here is the same except for the ends, okay? So everything is the same to the growth formula except for the compound. The compound is the number of compounds per year. Now, as I said before, so we're looking at the future value, okay? So the future value is going to be my A of t, okay? So we have the future value. All right, we have the initial value. So my initial value is going to still be that P sub 0. I have my rate. So my rate is still going to be my R value. Remember, we're going to need to convert that as a percentage. And then my T is still going to represent my time. All right, so my T is still going to represent time. Now, the difference is my N is my number of compounds. So when we're talking about the number of compounds, so when I say annually means it's going to occur 1 time a year. Semi-annually means it's going to occur 2 times a year. Quarterly, just like 4 quarters and $1, is going to occur 4 times a year. Monthly is going to occur 12 times in a year, and daily is going to occur 365 times a year. Now, this is all compared to a year. They may actually tell you the number of compounds. They may say N is 57 or N is 52, which would be weekly. So if they ask for weekly, you would say 52 weeks in a year. So you would have to really read the problem and see what it's saying when it says compound, okay? Now, we have compounded continuously. So don't confuse compounded and compounded continuously. Continuously is always going to be used with our natural base E, okay? Now, in this particular example, it gives me K. So, most of the time you'll see the formula is K, but K is essentially the same thing as the rate, Okay, so K is the same thing as your R. Now, when you do it continuously, that means that my K value is going to be greater than 1. So if it's positive, it's growth. If it's negative, it's decay. You're still going to convert it if they give it to you as a percentage, though. So my A of T is going to be my future value, just like before. Then I have my initial value with my P sub 0. Now, E is going to be my natural base. Remember, that is just a number. That's an irrational number that you're going to be able to type directly in the calculator. And your T is time. Now, the other two options are more specific options, but it's kind of a combination between growth and decay and compound. So we have what we call half-life and we have what we call doubling. So with the half-life, it's still set up the same way. So I still have my future value, I have my initial value, but my base is always going to be 1/2. Why? Because it's a half-life. A half-life means how long is it going to take for it to cut in half. So your base is always going to be 1/2. Then you're going to talk about the time and then how long it takes to half. Okay, so time is going to be divided by the half-life time. So if I say it takes 2 days to half-life, then you're going to put 2 in for the time and then calculate however long they ask you to do that. For doubling, I have my initial value. My double is 2 because it's going to times 2 is doubling. And this should say double time, not half-life. So this is going to be the double time and with the T. Now, before we go any further, the first thing that we're going to do is we're going to talk about how to convert to your percentages. So if I give you a function and I ask you, is it growth or decay and by what rate? You have been already telling me by growth or decay. So I'm looking at my base here. My base is 0.72. So if I take 0.72 and I convert that into a percentage by multiplying it by 100, that's 72%. So this is a decay problem, and it's a decay problem because it was less than 100% or less than 1. So how much is it decaying by? Well, how far is it from 100? So if I say 100% minus 72%, that means it's going to decay by 28%. All right, how did that come about? Well, that came about from my growth or decay formula. This right here represents 100%, and that 100%, you're going to add or subtract the rate. This is what we're looking for, is the rate. So here's my 100%, and we're going to subtract the rate here. That's what we're looking for in this particular example, or in these examples. All right, so for the next one, I have 3.42. So this is obviously going to be growth because it's much larger than 100. So I'm going to go ahead and take 3.42. I'm going to multiply it by 100, turn it into a percentage, which is going to be 342%. Now, how far is 342% from 100? Well, subtract 100 from it because this one's a bigger value. So that means it is growing by 242%. Okay. All right, so for the next one, I have 14.36. This is going to be growth because it's greater than 1. I have 14.36. I'm going to convert that into a percentage. And so I get 1,436%. Now, how far is that from 100%? Why is it 100%? Because that's where you started with 100% of the initial value. And that's going to give me 1,336% growth. All right, and the last one is 0.24. So 0.24 is going to be decay because it is below 1. It's less than 1. So we're going to change that into a percentage by multiplying by 100. So that's going to turn into 24%. So how far is 24% from 100? So 100% percentage, or 100% minus 24% means it's decaying at 76%. All right, so that's how we convert our percentages.